Hi, this is Dan. This is a Chapter 7 through 9 Solutions video, Fall 2014, for statistics. The first one here is trying to figure out if there's significantly over 50% of the people are getting relief from their symptoms. Our null hypothesis that it is 50%. The alternative is that it's greater than 50%. We calculate our z-statistic here and get a z-stat of 1. So so this is one standard deviation. This thing we experience, this 53.5%, is one standard deviation above normal. So that's saying, like, what's the probability that we would observe this if 50% is the population proportion. So if we look up 1 on our z-table, we get 0.1611, so about a 16% chance. That is greater than our significance level here of 0.01. So we failed to reject the null hypothesis. There's not significant evidence the proportion experiencing relief is greater than 50%. I mean, it is greater, but it's not statistically significantly greater. And then a type 1 and type 2 error. The type 1 would be, reject the null and say, yes, it is greater than 50% are getting relief, but it's really not. And type 2 error would be, say, fail to reject the null and say, nope, there's not significant difference, but there really is. And then a 95% confidence interval for this p hat here is 0.535 plus or minus 1.96, which is our z multiplier for the 95%. And then here's our standard error. And if you calculate that, so we would be 95% confident the true proportion that are experiencing relief is somewhere between 46 and about 60%. And it says, does the interval contain 50%? The answer is yes. Again, this kind of backs up saying there's no significant difference. And number 2, we've got the engine, average engine life, and it's supposed to be 235,000. They're trying to say if it's actually greater than 235,000, so that's our alternative. We calculate a t-statistic, so we find the difference. The sample mean was 243,450 compared to what we thought. Divided by the standard deviation over the square root of n. So we get 4.408. So it's like 4.4 deviations away. So it's really far away. So that p-value would be almost 0. And since that p-value is less than 0.05, we reject that null. And there is significant evidence the population mean of engine life is over 220,000. And then we calculate a 90% confidence interval. If you look on your t-table, and let me go ahead and pull up the t-table here. And this has 36, so I'm going to pull up the t-table here. So if I look at 36, which means 35 degrees of freedom, and we're looking at 90% confidence interval, so right there. So 1.690 would be our t multiplier. So degrees of freedom, level of confidence, 1.690. And so that's where this comes from, this 1.690. And so we would be 90% confident the true average engine life is between 240,000 and 246,000. And since 235,000 is not in that interval, that again backs up saying, yeah, it probably is higher than 235,000. It is significant. So does it contain that? The answer is no. And number 3, this is the difference between two proportions. So they're saying, is the defect rate the same or different? So the null is that these two manufacturers have the same defect rates. The alternative is that there's a difference. So it's a two-tailed test. Calculate this z-statistic, and we get negative 1.39. If you look up negative 1.39 in your z-table, you're going to get 0.0823. And if we double that, since it's two-tailed, so we get about a p-value of 0.1646, which is definitely greater than 0.05. Fail to reject the null. There is not significant difference in the defect rates. And then we calculated a 99% confidence interval. 99% confidence multipliers right here, 2.575. And there's our difference, plus or minus multiplier error. So we would be 99% confident the true difference in the proportions between negative 0.05 and positive 0.0, almost 16%. So based on this, is there a significant difference? The answer is no, because 0. If 0 is in there, it is possible that there's no difference. So, and that kind of backs up what we said up here. Number 4, this is a difference between two means. So our null hypothesis is the means are equal. And the alternative is that the mean of the treatment group would be lower than the mean of the control group. And this would be lower average blood pressure. So essentially, is the treatment actually being effective? Is it lowering blood pressure? I think it's systolic blood pressure, yeah. So our null is that they're equal. The alternative is that the treatment group would be lower, so we make this a one-tailed test, that mu1 is less than mu2. Our degrees of freedom is n1 plus n2 minus 2, so 61 degrees of freedom. And we calculate our t-statistic here, and we get a negative 1.48. And if we go ahead and pull up that t-table again, if we're going to look in row 61, but we don't have row 61, so we'll do the best we can, and negative 1.48, so let's look at that. So here's row 60, that's the best we can do, and 1.48 puts us somewhere in here, and if that's one-tailed, that puts us between 5 and 10%. So right there, row 60, 1.48, right there, between 5 and 10%. So that's why we would say the p-value is between 0.05 and 0.1. Since that's greater than 0.01, which is our alpha level, we fail to reject the null. There's not significant difference that the diet is effective or that it's significantly lower in reducing blood pressure. So the type 1 error is to reject the null and say that the treatment is effective when it's not. The alternative is that you fail to reject, say the treatment that makes no difference, but it really does. Number 5 is paired data. We're trying to do students how they do a memory test on them, and with and without music. So it's the same people being tested twice, so it's paired data. And I give you the mean difference, so the average difference between the before and after was 4.7 with a standard deviation of 1.3. So calculate a 95% confidence interval. So there's d bar, the average difference was 4.7, plus or minus. Now where does this t multiplier come from? Again, 50 minus 1 is 49. If we go back to that t table, 49 degrees of freedom, and we're looking for, what, 95%. So there we go, t-table, 49, we don't have that, so we got to go to 45, and 95% confidence, so right there, 2.014 is our t-multiplier. And so that's where that 2.014, their standard deviation divided by the square root of n. So we would be 95% confident the true mean difference is between 4.33 and 5.07 points, which would show, yes, there's a significant difference because 0 is not close to even being in there. So that confidence interval says it's effective, or that there's an association between listening to music and improved scores. Number 6, almost everybody missed this one. It's kind of tricky. It says the effect of music on teenagers. This says there was evidence of hearing loss. So that means there was significant evidence, which means they rejected the null. The null is that it wouldn't make any difference. The alternative is that it does. So that means the p-value is less than 0.0, was less than 0.1. Now the question is, would they have made the same conclusion at 0.01? Well, if the p-value, let's say, was 0.04, the answer would be no. It wouldn't quite be beyond that threshold. But if the p-value was 0.0001, then yes. So that's why it's a maybe for 0.01. And the same thing for 0.05. We don't know exactly where it is. We just know that the p-value is less than 0.1. So we don't know if it's left or right of these other lower thresholds. So that's why it's maybe for both. And number 7, the last one. You're supposed to calculate a 99% confidence interval for the deviation. We use the same data from the other one. And so you just take n minus 1, and if I'll pull up the formula sheet here. Here we go. Right here. So right here is a confidence interval for variance. So n minus 1 s squared. This is chi-squared right, and this one's chi-squared left, so we get those off the chi-squared table, and I'll show you how to do that. But we give you n, give you s, and you got to look up the chi-squareds. So there's 35 as n. There's the standard deviation. We square it, so it's 11,500. So we're trying to do a 95% confidence interval for the true deviation. So the only thing we need to look up now is chi-squared left, chi-squared right. And so if we look up on the chi-squared to 99% row 35, so let's go look that up. Chi-squared table. All right. And if we're 99%, that means there's 5% in each tail. So we use these outside columns for 95% or for 99%. And degrees of freedom was 35, but we don't have that. So we have to use the best we can. We can't assume more degrees of freedom, so we got to go to row 30 here. So we're going to use 13.787 for degrees for chi-squared left, and 53.672 for chi-squared right. And there they are. So there's chi-squared right, chi-squared left, and then we get a confidence interval for the variation, but we want a confidence interval for the deviation. So we actually take the square root of these. So take the square root of everything, and that's what you get. So we're 99% confident the true deviation is somewhere between 9,286 and 18,323. And that's it. So hope this video helps you review for the final or get ready for the next test. And we'll talk to you soon.